Okay, we have a doozy. It's cubed. All right, we need to find the derivative of this, and then we're going to state all the x values where the line tangent to the graph of f of x, dealing with slope, is horizontal. Let's just go ahead and jump into this question. Total slope means the slope is 0, right? Okay, so if I'm dealing with some curve, some cubic function, and I want to talk about the line tangent to that cubic function, but it has to be horizontal, then it's going to be here and here. We'll get deeper into this concept later, but it's going to be here and here. The slope is equal to 0. When I'm done finding the derivative, what I'm going to do is take that derivative and set it equal to 0 and solve it. But first I have to take the derivative, so let's do that. All right, this is what it's asking, or this is what we're going to do. That's our process. But let's find f of x plus h. I almost said x plus delta x. That's the other way of representing it. So x plus h cubed minus 27x plus h. And this one is going to be tricky. Trust me, just trust me on this. If I had x plus h times x plus h times x plus h, there is a fantastic way we could do this with a shortcut, but explaining the shortcut to get to the actual answer is going to take too long. It involves Pascal's triangle and what's called binomial expansion. It's beautiful. It is wonderful. I love it. It used to be in the Algebra 2 curriculum. It was a beautiful thing. But it's x cubed, 3xh or hx, x squared h, 3xh squared, and 1h cubed. Mr. Reader, where'd you get that from? I'm glad you asked. This is where it comes from. X plus h times x plus h times x plus h. Multiply it all together. Do it. This is what you'll get. Trust me. Okay? Love to waste your time with it. Love to teach you something that you don't even have to know moving forward. But trust me, it works. Every now and then we encounter some beautiful mathematics that I'd love to just kind of take a detour and be like, hey, look, let's try that. And we go off-roading, put the math in four-wheel drive and keep going, but let's not get distracted from the bigger idea. This is it, okay? So we're gonna take that big hoss of a mess, notice that I've distributed the negative 27, and we're gonna plug it in here, and let's do that now. All right, so there we go. We have the limit as h approaches 0 of, okay, you've seen the pattern on this. With the exception of that square root one, the polynomial terms from the original function are going to cancel. I'm just saying that about 2 minutes before we get there, or maybe a minute and a half. Ever how long it takes me to write this big nasty thing. So x cubed 3x squared h, 3xh squared, h cubed, minus 27x, 27h, am I still on the screen? Barely. Minus the original function. There we go. A little smudge there. All that divided by h, but we can't plug in 0 for h. There we go. Oh, my arm's tired. But that's what we have. All right, let's go for the obvious. Our polynomial terms from the original function are going to cancel. The original function cancels. X cubed cancels with x cubed. 27x and 27x both cancel. Okay, the next step, if you want to do it all at once, you can. May I? May I? I believe I will. Let's do it. Save some time here. If you wanted to write out an extra step, you can write out what you have left. You could factor the h out of all the remaining terms in the numerator, and then cancel the h that you factored out with the h in the denominator. But here's what it really ends up looking like about 2 steps from now. I would cancel this h with that, this h with one of those, this h with one of those, and this h with that, and that leaves me with 3x squared, no h's, 3xh to the first, h, not cubed, but squared, minus 27, no h's. Is it okay for us to plug in a 0 now for h? Yes. We would not be dividing by 0. If we plugged in 0 for h, this term and this term would go away, and we would be left with our final derivative of, not like there's a non-final derivative, but 3x squared minus 27. Yes, we found it. That was beautiful. But we're not done. But we're almost done, so trust me on this. State all the x values where the line tangent to the graph dealing with slope of f of x is horizontal. Horizontal slope, derivative equals 0. Set that derivative equals 0. We'll come over here and we'll do our work. So 3x squared minus 27 equals 0. Let's solve it. You know how to solve this thing. So 3x squared equals 27. X squared equals 9. X equals, keep in mind we are square rooting, so we need to take the positive and the negative. In the process of doing this, I have plus and minus 3. Final answer right there. Both of them are applicable. That's it.